Now, one other thing that I want to show you here is that you always can add a breakpoint in here. Add a breakpoint, just click next to the number here, and then you can go to the debug and continue to see how your program is being executed. So I'm going to click that little red triangle there and make sure that the watches are activated. The watches shows you what is happening in your variables. So here, as you can see, we have row variable, we have column variable, we have counter, and we have a matrix. A matrix has five elements. Those are 5 rows, and every row it has 4 elements. So the first element is 5, 6, 3, 2, and so on. The second element has these numbers because we didn't start executing this for loop, which will initialize these elements yet. So now we are at the second line, this line number 1. You can see the counter now has 1 because we initialized it there, and the row is basically 60, and the call is 8 because we did not initialize them yet. They get initialized inside the for loop. So I'm gonna click here this next instruction button here, and that instruction, whenever I click that button, the program will jump only for one instruction. So I'm going to click here, and as you can see, the program jumps to this inner for loop, and row there became 1. Okay, it got initialized by 1. So we jump there, we are inside the inner loop. So the first instruction, the matrix of row, call the matrix of 1, 0. So the value at index 1, 0 will get the value counter. Now counter has 1, so that the index 1, 0, this is it, gets 1. And as you can see, there's 1 in there. And then we do the inner for loop again, because call did not hit 4. We still at 0, right? Call is still 0. So call move to 1. So it's gonna, the for loop, this inner for loop here it's going to keep looping until call hit 4. We didn't hit 4 yet. And as you can see here, the second column is 2. Same thing again. Now the third column of the second row is 3, and so on, and then 4, and then we jump to the next line. And as you can see here, the execution instructions is here, but when I hit the next instruction, it didn't execute this inner for loop anymore. So it quit. It goes back to the bigger loop, the outer loop, and then row moves to 2, and then we're back to the inner loop again, and then and again we're filling now the second line. And as you can see, it's being filled, the second line, and then the outer for loop, and then the inner for loop, and then we're executing the inner for loop. So we're filling that line, and as you can see, that fourth line got filled. Now we still have the fifth line, so executing, and now we have completed. So here we have row is 4, but when we add 1 to 4 to the row, it becomes 5, but 5 is not less than 5. 5 is equal to 5. So we have to quit this outer for loop. And that's what we did. Now we're doing the same thing to print here. Okay? We're doing the same thing to print here, the same way. So we printed those 4 elements, and then those 4 elements, and then those 4 elements. And whenever I jump for another instruction, I print an element. Let me show you here. So I'm gonna jump, I print the next element, okay? And then the next element. So the next element that got printed now, it's 11 because the counter at that point is 11. So matrix of 3, 2 is 11. Okay, so that's matrix of 3, 2. So that's 0, 1, 2, 3, 0, 1, 2. So that's 3, 2. It has 11, and so on. So we print the final element, and then we jump to the next line. Now is the final row, and then we jump to the next line, and then we quit the for loop, and our program terminates. So basically that's a basic traversal of the matrix. Okay, we go from top left to bottom right, whether we want to put in elements of the matrix, whether we want to print the elements of the matrix. These are basically the two basic operations. When we study algorithms in a much deeper way, we're going to notice that matrices are being used a lot, and basically we're going to study a lot more sophisticated and complicated ways to traverse matrix to do more complicated ways. You might ask the question, why do we need matrices? Okay, how do they serve in life? And I'm going to give you one simple example. Now, the computer you're watching right now, it's made of a bunch of pixels, right? A bunch of diodes, a bunch of light-emitting diodes that are sending the lights right now to your eyes. And because there are so many, tremendously many pixels, many diodes, many very, very tiny lamps, light-emitting diodes, because there's so much, you cannot even see them. You just see an entire picture. What is that picture exactly? Well, that picture is actually represented in the computer as a matrix of pixel. So every pixel, every cell in the matrix has a color. Okay? Actually, every cell in the matrix has 3 variables inside it. So it's a struct. Every cell has a struct that has 3 variables. A variable that contains the green color, a variable that contains the blue color, and a variable that contains the red color. And dependent on the combinations of those 3 numbers, we get the number we want. So if you've written HTML before or any design, you know what I'm talking about. So all of those operations, very sophisticated operations that happens on those pictures are actually happening on matrices algorithms. If you have played video games before, then you know the importance of graphics. All of those graphics, when you play the game, like a lot of geometric calculations are happening just to produce the final image that you see. So those algorithms are actually executed on matrices, okay? So that you get the final nice picture, a bunch of pixels together. Okay, so when you, for example, open up a photo editing software like Photoshop, you're actually, the Photoshop from its inside actually using matrices in order to represent those pictures, in order to do customization, in order to add darkness or white effects or whatever effects you want. Okay, for example, if you'd like to add a blur effect to your picture, you're actually asking Photoshop or any editing software to loop through the entire matrix, just exactly the same way we did, okay, from top left to bottom right. So 2 for loops nested, 2 nested for loops, and then for every cell we take the sum of the 2 adjacent cells and we divide that by 2 or by 3 or whatever. So we take the median. And by calculating the median of the whole matrix, we've actually did a blur effect on the picture. So that's a very, very popular example on where we use matrices. I hope this is a motivation for you to start learning algorithms and major on them, because they're really, really cool. Okay. So thank you for watching and see you in the next video.